fellow riders, and welcome back to Airhead Barn. Our restoration project of R75/7 is almost coming to the end. In last couple of dozen of episodes we were able to show you how properly to disassemble a whole bike, restore basically every component of it. And before we start putting things back together, there are essentially two more parts that I would like to take a look at and rebuild. The first one that I'll show you in this episode are forks, and the next one will be wheels. So in the previous episode I showed you how Koni shocks can be rebuilt, and in this episode I'll show you how to rebuild and also upgrade these front forks. These forks are a bit different than the standard forks that you can find in modern bikes. I'll show you that once when we start taking things apart. And the upgrade that we are going to do here is essentially race stack valve emulators. I did this conversion or upgrade in my R80 ST, and the result was really good. It's a bit more involving. They are not just drop in, and I'll show you how to do everything from a beginning to the end. They also come with a pretty good instructions, so I suppose there is no many things that can go wrong here. So please stay tuned in this episode where I'm going to show you basically how to do this modification. Okay, so first thing that we will need to do is a clamp tube inside the vise and a soft jaws that will help us to remove damping rod, which is very important. That's how we start. So let's first remove this nut here, wave washer, and then there is a original copper crush washer that is fabric filled. My rebuild kit that I ordered came with aluminum, which is still fine. We can use that one instead. Okay, so next thing, here there is a snapper ring, and you will need snapper ring pliers to remove this one. It's pretty beefy and big, and there it is. Okay, first that goes out. Now you can still use same snapper ring pliers, and inside there is actually a nut that needs to be unscrewed. Okay. And you can basically use, again, as I said, your snapper rings for this, snapper ring pliers for this, because usually it's not pretty tight. There it is. And now you just unscrew it. Okay, there it is. Next thing that we have inside is this aluminum spacer, just like that. And then behind spacer there is another nut similar to the one that we already removed, but oriented in an opposite way. So we will also unscrew that one in the same way. that's the other one. Okay, now we should be able just to slide everything out as a whole. And this is our damping rod with a piston and essentially piston rings similar to the rings of a cylinder piston. And this is a plastic spacer again. This one will be replaced. And now we are going to work basically on this damping rod. So I'll talk about that in more detail following the instructions, what's necessary to do in order for gold valve emulators to be able to work with this design. So without further ado, let's proceed with that. Okay, so first thing that we will need to do is disassemble this damping rod in order to remove a ball and a spring that's inside and it's used for damping. We are not going to need it since we are using racetrack emulators, and that means that this actually bolt needs to be unscrewed. Usually these are very stubborn, and in order to unscrew them it's a good idea always to clamp them in a soft vise. Then you will need to use something to hold the rod prevent it from spinning, and in the same time I'm going to heat up this part of the damping rod so it's easier to unscrew it. Okay, just pull it a bit more out so I can. Okay, that should be enough. Let's heat it up. Okay, there it is. We are going to remove, we are not going to use this spring and a ball that was using for damping. Okay. Alright, now these holes are a bit different size. They vary from like 4.5 to 5 millimeters, and they will need to be drilled to 6 millimeters. So each one of these, if you look, there's 4 holes on this side and then 4 holes here, so total 8 holes which will need to be enlarged to 6 millimeters. So that's our next task. So after drilling all 8 holes to 8 millimeter, and I did this with my drill press, but you can use it with hand. You can do it with hand drill as well. It's time to debore the holes. This is very important because you don't want to leave anything sharp here that can later on detach and be inside the oil, because it can actually destroy valving and piston rings that you have there. So the next thing that we need to do on a piston rod is actually cut off this portion of it, because it's not used with gold valve emulators, and essentially here where shoulder starts, that's where you will need to cut it off. You can go fancy and use lathe for this, or regular hacksaw will work as well. Okay, and the reason why we are cutting this is, basically for emulator to fit, because like this it cannot fit, so that's why this needs to be open. Okay, now we will blow everything with a compressed air, and then we can start the assembly. Okay, so after we are done with enlarging these holes to 6 mm and deburring them, I also cleaned everything, and I deburred this remaining part that left after we cut off the top piece to be able for this damping rod to accommodate gold valve emulators. Now it's actually time to rebuild the damping rod. And as I said previously, this is very interesting design where you have a piston and then piston rings. Modern bikes usually don't have something like that. It's newer Airheads also have a different system. So here I have my rebuild kit, and these are rings that I'm going to use there. And okay, let's see what else I have here. And this is for like this actually crush washer, and then a cover as well, new seal, new rings that we will put now, plastic damper that goes in the leg as well, and then this guy I'm actually going to use here as a crush washer. Okay, right, so first these, it's very easy to remove them. One out. I can do two at a time. Okay, all three are out and they are all the same. Okay. You want to orient them similarly to engine piston rings, so 120 degrees offset. Like that. Okay. That looks perfect to me. Now on this side I'm going to change this plastic damper, which helps basically when fork is bottoming, that damping rod is not hitting the leg, but it has this bumper. This is how it goes. And now we can put this guy back, but without that spring and the ball. Okay, tighten everything with 13mm. And this is an aluminum crush washer that came with a kit instead of a copper one, but we can still use that one. Okay, and now wave washer and the nut. Okay, so now our damping rod is ready to be inserted in a tube, and this is how it goes. We will need to adjust the gold valve emulator. So when you buy a kit, you receive a code that you enter in their system, and then system actually spits out all necessary information for your weight. So oil that we are going to use is weight 15. Oil level is 120 measured from the top of the fork. Spring rate, for me, the calculated one was 0.79. They provided the first closest, which is 0.8. Preload that we will need to do is 50 millimeters, and I'm going to calculate what the plastic spacer that they provided needs to be cut at in order to have 15 millimeter of preload. And later, when you put everything together, you can actually measure what the sag is. Okay, so if we look here for the emulators, they say blue spring color, the one for me, and that one is already pre-installed here. And they also provide like other two springs that can be used if, you know, if I gain some weight or lose some weight, or owner is changed. And then it says 2.25 turns, so 2 whole turns and 1/4 of a preload, and that's what we are going to set. And then 3 bleed holes. So this one already have inside something like this, and it has 3 holes already pre-drilled for me. But if for any reason I would need to change, you know, the settings, they provided the extra part where you can actually drill as many, up to 4 holes essentially, to accommodate for your weight. Okay, so 2 1/4 turn, that's the next thing that we will need to adjust. So how to do that? Here I'm using an Allen wrench, and on the lower side we have a lock nut. So first we are going to loosen the lock nut and drive it out of it. This lock nut has you know, like a plastic locking, so it goes pretty hard, so keep that on your mind when locking this thing together, that you are not turning the screw, because that will basically reset your settings. Okay. Alright, so now I'm going to unscrew this one. Okay, now it's completely loose. So this is what we are going to do. I want to screw it in until this bolt touches the plate, so they can still freely move, and that's like my reference or initial setting, that's 0 preload. Okay, so now I would need to set a reference point. For instance, I'll use my Sharpie. So this is 0 preload, this is no preload at all. The bolt only touches these washers. And I'm going to mark this bolt at 12 o'clock, and that's where it actually faces this indentation here. So this indentation of my emulator. And now I'm going to start turning it and count. This is 1 turn. This is 2 full turns, and now I just need a quarter. Okay, that looks at 3 o'clock to me, so that's basically 2 full turns and 1 quarter that I just did. Okay, now we will need to drive back this lock nut, but make sure that you are not turning the bolt as well. Okay, so I'll try to keep everything stable in my hand. With fingers I'm holding the emulator, Allen is inside and in my hand, so everything should be pretty solid there. And then I'm just rotating this lock nut. Okay. And then if I check again, I'm still at the same spot. I'm just going to tighten it. And that looks good to me. Okay, and that's how you set preload of this emulator. Okay, now that's ready as well. And final thing that we are going to do before we actually put things back together, we need to inspect this tube. Okay. So I'm going to use dial indicator. So I set my dial indicator to measure to see how flat, how straight these tubes are. First you want to do reference measurement over the post, because that will give you the idea if there is something wrong with the post, if your needle is jumping there. I don't expect it here, these posts are pretty good, but that's always, you always need to have some reference measurement. And then we will move it toward the middle side where actually you would expect the most of the bend. So here we are, dial indicator is set to 0, and now we can start rotating this tube. So we can see that like 1/1000 of an inch we have the irregularities on a tube or a post, and that's our reference measurement. Now we are going to move this dial indicator on several spots in the middle of a tube and repeat the measurement. Okay, here is another spot. And again we are not getting more than that 1/1000 of an inch. Now we are going to move it more further. Okay, we are at 0 again. Okay, still 1/1000. And third location. So same thing, which means that these tubes are actually this one, and the same was true for the left one. They are in terrific condition, so we can proceed with the assembly using these. If they had significant offset, and you can find that in a manual, then we would need to replace tubes. Now we can proceed with installing a damping rod inside the tube. And to do that, you will need something to compress those rings to fit inside the tube. And similar to like engine piston rings where you need a compressor, this is a tool available from BMW that you essentially screw in, and then it has a very slight taper inside that is used to compress the rings, and basically you can feed the damping rod inside. Okay, you just screw it in, and now we are going to take alright, so here we have our damping rod, we have adapter that was provided in a kit from a racetrack that goes over this part of a damping rod, and then here you have an emulator, and then on top of that you are going to have a spring. So here is a spring. So the spring will later be removed, but at this point it's going to help me to hold everything in place so that my emulator or adapters are not somehow crooked like this and then standing in a wrong position. But this is how everything is basically standing inside the tube. And then on the top you have your preload. Okay. You have your preload spacer and then a cap. Alright, so first I'm going to feed my spring, and then just last check that rings are 120 degrees apart, and they are. And now we will insert this thing. Okay, just like that. Alright, so now I have it, and now I need to insert it. There it is. Okay. Perfect. So at this point I can remove tool. I don't need it anymore. Now we are going to put this plastic bumper. Okay, that's great. And then first nut oriented in such a way that opening goes toward you. Okay. So now we will rotate it until it's completely screwed in. Okay, and we are going to tighten it in the same way as we unscrew it with snap ring pliers. You don't need to go crazy with this, just a slight pressure is all what's needed. Okay, that's it. Next thing is aluminum spacer. Sits just like that inside that nut, and now second nut oriented in the opposite way, so this part looks inside and this part looks toward you. Alright, that's enough. And finally, we are going to put snapper ring. Sharp side goes outside, chamfered side goes inside. And that's it. With that, we are done with putting our damping rod back in. And now we are going to focus on setting preload. To set the preload, I have a tube mounted in a vise again, in a vertical position. And now my spring is already inside. Next thing I want to insert is a washer, because you don't want spring to rub directly on a plastic, and that's why we are going to use this washer between plastic spacer and a spring. So that goes inside. Okay, next thing that you need to do is measure a distance between this edge of the fork and that washer that you just threw in. And in my case, this is 79 millimeters. Okay, so that's the first number that you want to write down, 79 millimeters. Now, if you look at the cap, this cap will not be screwed all the way to the tube, but basically we will have these guys sitting between. So to your preload, actually to your measurement of 79 millimeter, you need to add thickness of these two plates, because that's how it goes. So this is how it screws in, and then you want to count that in as well. Alright, so if I measure these two together, I'm getting 6.7 millimeters. And you can do measurements at the different locations and then do the average, but this is 6.7. Okay. Now we are going to do simple math. So I had first measurement of 79 and then I had 6.7, which totals to 85.7. Okay, now our spacer will go inside tube like this, which means that I need to measure from this point where spacer touches the tube, where spacer touches the cap, all the way to here where this nut is going to touch these two plates. It's going to be screwed in just like this and all the way. Okay, so that's my next measure. So from this surface all the way down. Okay, and I have here 23.7. Alright, so if I do now, I need to subtract that number, minus 23.7, and that brings me to 62 millimeters. So that would be my spacer without any preload. That means if I put 62 millimeter long spacer inside, that spacer would just touch my cap on the top and my washer and spring on the bottom. And instructions tell me that I need to have 15 millimeters of preload, which brings me to 77 millimeters of a plastic spacer to achieve 15 millimeters preload. That was basically given in this worksheet. So this is where they state 15 millimeter of preload. Okay, so the kit comes with this PVC tubing, and you need to cut it to the measurement that you have. For me, that's 77 millimeters. And I found the best actually way to do that is using like a tube cutter, because this does not leave any boring, and it creates perpendicular cut, so it's very convenient for this kind of application. And here I already have a spacer that is that I cut to 77. Yeah, this is the one, 77 millimeters, and that's the one that I'm going to use. If you end up cutting it a bit more than it's necessary, just put a sandpaper on a flat surface and just sand it like this. It goes pretty quickly, and that's the thing. So when I put this guy in, it should be almost to the top of the fork tube, and that's how my other fork looked like. So I know they are exactly the same. Alright, and basically now I can essentially screw my cap in, and that part is finished. The next thing that we are going to do is focus on fork leg. So here we are with a fork leg. First we are going to remove old seal, and a regular seal puller will work just fine. Just don't go too deep so you scratch the leg. Okay, next thing we need to remove this nut, 36 millimeter. So we will replace this crush washer, and then it seems someone put this one in opposite way. So I'll need to remove it. And this bumper. And we have a new one that we will use instead of this one. This is the correct way how it goes in. Okay. So this came with a rebuild kit. There it is. Nice. Now we are going to clean everything and then we will put everything back together. So we are back. Everything is well cleaned and now we can start with the assembly. Before doing that, I would actually like to show you what can happen if you push that seal puller too far and you don't pay attention. So here, I hope you can see the scoring inside, right there. Yep. So honestly, I have no idea when that happened. This is new to me bike, but probably during some of the previous seal changes, someone was not careful enough and they actually pushed the puller too far. Well, luckily there is a cure for this, so we are not going to put seal just like that. I'm going to use this liquid gasket in that place and then push the seal, and hopefully that will be good enough for seal not to leak. Luckily this is not too deep, so I don't need a lot. Just like this. And then I'm going to have it on a seal on that side as well. That should be enough. Okay. Now let's put seal in. First, you want to drive it as much as you can with your fingers. Okay. And now we will get a socket to finish this. Don't use seal driver because this seal actually has a lip, and with a seal driver that's flat you are going to destroy that seal lip. So for this application, this 32mm socket works really nice, and I'm just going to drive it in. That's it, all the way down. Now I'm just going to wipe the excessive silicone, and that should be good enough. Now I'm going to put some grease on a seal. I have here Racetech grease, but you can use regular high temp bearing grease. That's going to work fine as well for this application. Okay, that's enough. Okay, so first I'm going to prepare everything like a bottom cap for installation. Plastic bumper goes this direction inside, and then our copper washer. I like usually to put seam up. I think it doesn't matter too much. And then in the same time, this aluminum crush washer needs to go on a damping rod, but when I flip damping rod to put it in a fork leg, it can fall down. So for that reason I'm just going to put a tiny bit of bearing grease on this washer, so it's held in place once when I turn it upside down. And that should keep it Now we can insert the cap. Just like that. And now 36mm socket. I'll first drive it with this one. And now it says 80 to 100 Newton meters, which goes 59 to 74 foot-pound. I'll go with 74. Now we can install tube and a damping rod inside. I'll most likely need to fish it out. No, actually it went through. It usually doesn't happen like that, but that's great. And now we can put wave washer and a nut. Okay, and this needs to be torqued to 25 Newton meters. And that's why it's a good idea to have spring inside, because spring prevents a damping rod from turning, and it should be enough to enable you to tighten this nut to 25 Newton meters. Our fork is mounted in a vise in a soft jaws, and the fork is fully compressed. The jaws are attached to the fork leg. Spring is out, spacer, preload spacer is out. Washer, basically only inside part that you want at this point is damping rod, then that adapter, and also the emulator. And now we are going to fill this thing with oil. And it says that oil level needs to be 120 millimeters measured from the top of the fork. And how I'm going to do that? I'm going to overfill it, and then I have this very simple thing where distance from between this point and the end of this hose that I have here is exactly 120 millimeters, and then I'm going to remove the extra oil from the fork. Okay, so let's proceed. Here I have a pretty big syringe that can do 150 millimeters, and I'll do two of these, so 300 inside, and that will definitely overfill it, and then we will pull the extra out. This is first 150. This is Spectral 15 weight oil that came with, that's actually recommended by Racetech, and that's what I'm using. Now I want to pump it a couple of times up and down. there's a lot of air and you need to get rid of all air before putting a cap. Okay, let's do another round of 150. And now we will continue airing it for some time. And you are done once when there are no more bubbles coming out. Okay, no more bubbles, and now we can proceed with the removal of the excessive oil. And a good idea is actually to measure that oil, because we know that we put 300 milliliters in. If we remove, let's say, 50, that will mean that for one fork for the future oil change we need only 250 milliliters. You could also measure once when you are changing whatever comes out, but this is actually a really good time to set the amount of like a volume of the oil that goes inside. Okay, so for that purpose I'm going to plug this big syringe just like that, and then I'm going to fill it up with the excessive oil, and that's how I'm going to measure it. Alright, so this guy goes inside. Okay, it seems we are coming to the end. I'll try once more if I can pull out anything else, but I think we are done. Okay, that's it. Okay, so now if we measure exactly 35, okay, and that means instead of 300 we put inside 265, and now we know for the when we want to replace that, change that oil. Okay, looks good. Now I'm going to just put the plug back in. I'm not returning spring because I want to check for stiction if forks are properly aligned, and I cannot do that with a spring. So once when they are installed and stiction is good, then I'll actually put the spring in. Okay, so with that, this episode is concluded. Race stack gold valve emulators are in. Spring will also be in once when forks are on a bike, and I hope this is going to actually be a really nice addition to this bike with original look. Thanks for joining and for watching.